Hello and welcome back to Science, Mr. Robertson, and today I'm going to talk about the weather in some detail. And we have lots of weather. Like we have sunshine, and we have wind, and we have rain, and sleet. That's like the bit of rain that's kind of mixed with the snow, and it's horrible in November. And we have hail, hagel, and we have thunder and lightning. It's very exciting. Loads of different kind of weather. Today we've got to look at a bit of how and why it kind of works like this. Firstly, let's put all of these into a group here. All of these here, let's remember, are types of precipitation, which basically means water. Any water falling down, well, you can't see. It says water. Basically, anything where you have water falling from the sky is precipitation. If I have rain, now rain is a liquid, so remember rain will go to the bottom when I measure how much. If I have snow and it falls, it's a lot more fluffy. Like there's lots of air in the snow. You know, if you make a snowball, you can crush it together. So if I want to know how much precipitation, I must melt everything. So as a liquid, och sen ser hur mycket det faktiskt var. Awesome. Now, weather, and why we have rain, why we have the winds, and so on. Okay. Firstly, let's remember that our Earth is not perfect. For a start, the sun is over here, making it hot, and our Earth is a bit like this. Of course, if I do that, I can tell it's summer because the north part of the Earth is facing towards the sun. This much here is very, very important. It's important because if I have the sunlight like here, two things happen. One, remember the Earth spins on its axis. So if I'm leaning towards and I'm spinning, the day is a bit longer than 12 hours. In summer, it is hotter for one reason, because day is longer. A longer day, of course, means more time for light to shine. Another reason is that the light is actually stronger. Not because the sun is like, more light, have more light. The sun is pretty much always the same. It's because if I take these two arrows here, they cover this point here. But if I look at this here, the other side has a much bigger area. The light is stronger because all of the energy is focused more on one point. So you get more energy in one place. It is stronger light. We have that. And that means different parts of the Earth get different temperatures. At the middle of the Earth here, where it's more flat towards the sun, it's going to be more light energy and hotter temperatures. The bits that are kind of curved away, well, they only get a little bit, so they get colder. That means we get hot bits of air and we get cold bits of air. And they move around the Earth all the time. What we have things then called fronts. We can have cold and hot air fronts. A front is basically moving air. Now what we have to remember here is from our density. So remember that if it's hotter, it needs more space. So it goes up. And of course, if it's cold, it will go down because it is more dense. So we have a little bit of a difference there between the two. Cold going down, hot going up. So, you might can't see that. I will do it over here. No, I won't. I will do it. I'm too much in the middle. Let's say I have some cold air coming through like this here. I have a better pen. Some cold air like this goes through. And then I have, it's meeting some hot air. This is hot air here. Of course, my hot air is going to start going up. And my cold front, here's my cold front like this here, the cold air going quickest along the ground. What happens is this hot air just keeps rising up. But the higher up you go, it gets more cold. It gets more cold, and then, of course, colder air, some of the water vapor, vatten ånga, maybe you will get condensation. And if vatten ånga kommer till vatten, what we can get then, we might be able to get clouds. And the same, the opposite way, if hot air is moving, maybe the hot air goes up and we can make clouds and make lots of rain like this. Usually when we get big temperature differences, we get some of the biggest storms. And of course, to do that, we need to get our planet super hot and changing all the time. So we, of course, need to remember that if I have, let's say I have some air here, and I have 10 bits of air here, and I have 5 bits of air here. What's going to happen is when I take this door away, they're going to spread out, and they're going to go in all crazy directions, but more will go in this direction. I'm making a wind. A wind is a movement of air from high, what we call pressure, which we'll do later on. Det finns mer atomer på en plats som tryck. That's a pressure. They're moving around much more to the low pressure. So the air is always moving around where there's lots of air pushing away to where there isn't very much. And we can see examples of this when we look at a nice, simple day and night situation at the seaside. Here's my seaside. Here is my land. Like so. Now, på dagen det jättesoligt. This here is a good conductor. The sea is more of an insulator. So, that means this one gets hottest fastest. This one is going to get hotter. It has more hot air right here, and this hot air goes up. If it goes up, now there's no more air here. Where has all the air gone? So I get more air coming in like this, what I call a sea breeze, usually during the day. And of course, this would continue, so it'd have a pattern that looks like this. Hot air going up, and this pattern here. If I switch it instead to be nighttime, well, now because it's an insulator, the insulator keeps the heat better. It's hotter here at day, but it's colder here at night. So, what happens now, this is the hot going up, this is the air coming to the place, and we couple the rest. We have at night something instead called a land breeze, rather than a sea breeze. We see that during the daytime. That's the basics of weather. We'll do a lot more on weather, but this here is a little clue as to how some of the systems work. There'll be a little question in your thing to think about. Thank you very much.